All right, welcome back, geometry students all over the world. I just found out recently that some students over in Saudi Arabia are watching my videos, so shout out to Lean Al Jeffrey. Thank you so much for letting me know how far I'm reaching. That's pretty awesome. We're going to continue our unit on triangles. So far we've covered interior and exterior angles of triangles. Now we're going to start talking about congruent figures. And what we're going to discuss in this lesson is kind of basically a long cut to what we're going to be doing eventually in the unit. So in congruent figures, we got to start learning about finding congruent parts, using congruent parts, finding congruent triangles, and then proving triangles are congruent. Woo! Proofs. Yes, yes, proofs. It's about time, Mr. Katz. I know, we all love proofs. So anyway, let's dig in, shall we? Let's go. So we got a couple of notes here that we should look for. And the first thing we're going to talk about is what are congruent figures. So here is an example of a couple congruent figures. We're saying that this figure is congruent to this figure, then it's a list of all the parts that are congruent. So since this figure is four-sided and this figure is also four-sided, we have 8 potential congruent parts. That's important to note. So we have 4 sides, 1, 2, 3, 4, and 4 angles, 1, 2, 3, 4. Okay, so we have 8 possible congruent parts. What we have to do in congruence, though, is be very, very careful about how we're reading things. So in this first part of the note, where this figure says that segment AB is congruent to segment EF, look at how that works. We have in the first figure segment AB, which is read this way. And we know that, well, if this figure is congruent, well, we can't call it FE. We read it AB, so this has to be read EF. That's what's congruent, AB and EF, not the other way around. We cannot call it the other way around. We cannot say segment AB is congruent to segment FE. That is totally incorrect. We can't say that because it's going, AB has been read up, so EF has to be read up. And the same thing with segment CD. CD is read going from basically the long side out to the short side. So segment GH has to be read from the long side out to the short side. So it's so important about how we read things. So that's the first key concept. When we look at congruent figures, the reading matters, okay? Reading matters. So we have to be careful with how we're reading the shapes. It's so important to note. So this is segment ABCD, ABCD, and this is figure EFGH, EFGH. Now, there's another way to cheat your way through here. We can totally cheat. So check this out. Segment AB is right here. So segment EF is right there, right? And we can look at segment DA is congruent to segment HE without even looking at the figure, right? DA and HE. Now let's look at the figure. DA going up on the short, HE going up on the short. So you can even just look at the coordinates on what is congruent to know congruence without even looking at the figure, and that's a cheat way of doing that. And we can talk about angle C that would correspond to angle G. Okay? So this is all about congruent figures and what things are corresponding. Okay? So we got to talk about corresponding in the same order. So when you're looking at the definition, corresponding in the same order. So that's the key note. If that didn't make any sense, this is a great time to pause and rewind and watch again to make sure you understand how figures are read if they are congruent. The second note we have to talk about is what's called the third angle theorem. And the way that's read, if 2 angles of one triangle are congruent, then the other angle must be congruent. It just must be. Right? It's a theorem because if the 2 angles are supplementary to the third, well, then they're the same measure. So anyway, if we look at the note here, we have angle A being congruent to angle D, right? 1 arc. And angle B being congruent to angle E, 2 arcs. Then what third angles theorem says is that angle C will make it 3 arcs. Boom, boom, boom. Must be congruent to angle F. Boom, boom, boom. So if you got 2, you have to have 3. And that's kind of the note for that. So these two notes are important. If anything was too fast, hit pause, rewind, slow down. Make sure you have these notes. That's super important. Let's do some work, shall we? All right. So here's the first question. We have two figures here. I should probably hide this stuff. Don't look. Don't peek over there. All right, there. So I'll hide this stuff. So we have the note here. So if Hij is congruent to LMNO, what are the congruent corresponding parts? Okay, so we have Hij and LMNO. Now we have to figure out what corresponds. Okay, so if they're congruent, right, these two shapes are totally congruent, we're telling you that, what corresponds? So first of all, let's look at the sides, right? HK is the long side, and over here is the long side. Then HI is like the base, and maybe this is like the base. And then it goes around here. It goes HIJK. So what is it congruent to? It's congruent to LMNO. So LMNO. Look at how this one's being read this way. This one's being read this way. It's so important in reading. So one thing you might want to do, it's up to you. One thing you might want to do is make your second shape in the same direction as the original figure. So that way you can know that better. So this shape goes much easier to see, LMNO, right? HIJK, LMNO. It's so important to know that things are read in the same direction, okay? So that's a critical element. Do you need it? No, you don't need it. Because remember, there's a way to cheat, and I'll tell you that as well. So then we look at some corresponding parts. I'm not going to do all 8. I'm just going to do 3. Okay, so just 3 examples. I'm not going to do all 8. So the first example I want to give you is segment KH. So here's segment KH, and we're going to read it this way. Okay, so we're going to read it this way. Now, it's the long side, right? If this is the base, it's kind of like the long side going down. Well, which side is that on this figure? Okay, so we have to know clearly we're talking about this side, right? We're talking about the side here. That's the side we're talking about, but which way is it going, right? So K is going from basically the top to the base. So now we have to look at the same thing here. This is the base. LM is the base, just like HI. So we have to read it this way. So what's going to be corresponding to that segment, KH, is going to be OL. They totally correspond. And so how can we look? Remember that figure when you rewrite it? OL. Okay, it's the same way. Now the third way to do it, we can totally cheat. KH is here in the letters, right? It went to KH. So what corresponds to that? OL. You can totally cheat that way. No matter how you see it, it's all good. Either way, the correct response is KH is congruent to OL because those are what's corresponding. You can't write it the other way. Okay, if you call it HK, then write it LO. All right, so that's just the one example. I'll just do 2 more and call it a day for this particular figure. Another corresponding segment I want to look at is IH. So let's look at IH going this way, right? It's the base, but from the short top to the big top, right? So IH is from the short top to the big top. So we do the same thing. IH from the short top to the big top. ML, or from once we move the figure, ML, or we can cheat. IH. IH is going backwards this way, so ML going backwards this way. No matter what, you can totally work on corresponding congruent parts. Okay. And then lastly, remember there are 8 parts that are congruent. So angle O, if angle O, what's that correspond to? It's the big top from the base, right? The big top from the base. Or when you cheat, angle O is the last letter. So K must be the corresponding angle. Look at all these different ways you can cheat, right? So angle K. So there's way more than one way to skin a cat, as the segment goes, to fool a cat. More than one way to answer a cat. Anyway, so that's and there's 8 of them, like I said. So let's do another one. Now I'm going to give you another question, but this time no picture. Totally no picture. So let's do this without drawing a picture. Let's just go ahead and label all the corresponding parts. Okay, so all the congruent corresponding parts. So we have triangle WYS. Okay, so in fact, let me just make a triangle real quick so we can figure it out. There's W, there's Y, there's S. So remember, triangles have 6 parts. We have six total parts. So three angles, angle W, angle Y, and angle S. And then we'll see what they are congruent to. And then there are 3 sides. Okay, so we'll call it segment WY. And we'll call it segment YS. And then we'll call it segment SW. Okay, so notice how we're reading that. So we're going to look at we have our 3 angles and our 3 sides. WY going this way, YS going this way, and SW going this way. So we can totally cheat. Notice what angle W, right? Angle W will completely correspond with angle M. So we know it just by the letters. It's going to be angle M is what angle W is congruent to. Right? The same way, angle Y is the middle coordinate, so the middle coordinate is going to be angle K, corresponding congruent to that. And then the last one, angle S is congruent to angle V. Isn't that a neat way to cheat? You can totally do that without drawing a picture. Same thing works with the segments. Okay, so with the segments, we have here segment YW. We know we read it this way, but without looking at the picture, here's segment YW. So what's going to correspond? MK. Boom. So MK corresponds. YS corresponding to segment KV. Boom. And then segment SW corresponding to segment VM. Boom. Okay, so we can work on corresponding parts that way. You can draw pictures, you can use pictures, or you can find your way to cheat. Either way, that's how we find congruent parts. Okay, so we're all good on finding congruent parts. Yay, yay. Okay, next. Now we're going to use congruent parts. Ooh. So let's take a look at this. Suppose that these 2 triangles we talked about before are congruent. Now if the measure of angle W is 62 and the measure of angle Y is 35, and all right, I'm already falling asleep. I can't even follow this. So you know what I like to do? Draw a picture. Yay, pictures. So let's draw a picture. We got 2 triangles that are congruent. Okay, so let's go ahead and do that. Let's draw two triangles that are going to be congruent. We got triangle WYS, and it's going to be congruent to triangle MKV. All right, so now things are going to start making a whole lot more sense. If the measure of angle W is 62, I don't want to think without looking too hard. So that's 62 degrees there. The measure of angle Y is 35. Okay, and that's there. Then what is the measure of angle V? The measure of angle, what? Wait, what? It's not asking for the measure of angle S. It's asking for the measure of angle V. Dude, it's asking for those, that measurement there. That's the question. So you have to understand what's the question. And like I said before, it's going to be hard to see what's being asked if you're not drawing a picture. So when in doubt, draw a picture, and that will totally help you. Okay, so these 2 angles are 62 and 35. Now, what do we know? We know that these 2 triangles are congruent, right? Same size, same shape. So we already know that all the corresponding parts are going to have to be the same, right? So if angle W is 62, then angle M is also, guess what? 62, which means angle Y being 35 means angle K is 35. Now, how in the world are we going to find angle V? Remember, the interior angles add up to 180. So you got to remember that. Interior angles add to 180. Interior angles add to 180 degrees. So it's important to know. So we have our first 2 angles, 35 and 62. That's 97, right? So if these 2 add up to 97, all we have to do is subtract that from 180, and we'll have the remaining angle. So it's just like in the previous lesson. Funny how that works. Remember I told you I rearranged some stuff? Yeah, I did that on purpose. Anyway, we're going to regroup and give that 0, turn it into a 10. 10 minus 7 is 3, and then we took the regrouping there, so that's 110 less. I can't do that. 17 minus 9 is 8, right? Okay, 83. So now we know that the correct response there is 83. So the measure of angle V must be 83 degrees. Okay? Okay. So that's how that works. We just used congruent parts. The 2 triangles are congruent, so each of their parts are congruent. Okay? So that's the major jump. So hopefully you noticed that for this one. Bloop, bloop, same, bloop, bloop, same. Therefore, that one has to be 83. Cool? Yay, using congruent parts. Let's do another example, but this time with a jet. Whoa, all right, because the book thinks if I draw a picture of an airplane, young boys will become interested in geometry. So Young boys, are you interested in geometry now? Yeah, because look, there's an awesome SR-71 Blackbird. Whee! Anyhow, the wings of the SR-71 Blackbird suggest congruent triangles. What does that mean? It's telling me the wings are congruent triangles. Therefore, see that those wings here are congruent triangles. All right, so that's what the whole thing is saying. The question is, what is the measure of angle D? That's the question, right? So here's angle D way out there. Bloop, bloop. So that's the question. What is the measure of angle D? Well, look what we have going on. Remember, it says they are congruent, right? So if these are congruent triangles, look at ABC. See that triangle ABC? You see angle C is 75. Guess what you know about this triangle over here? Yeah, very good. Okay, angle F must be 75. Okay? So now we are all set to answer the question because we can totally find the measure of angle D. Angle E is 30. Angle F is 75. If I add the two, I get 105. And what do? I subtract that from 180. And guess what? We now know that the measure of angle D is 75. Now we know something else called an isosceles triangle, but whatever. So the correct answer is answer B. In this case, it is 75. Okay. So if you were confused before and you like planes, well, now you know geometry because that's the thinking behind this. Anyway, snarkiness aside, let's move on. So now what we're going to do is find congruent triangles. This is where things get screwy. So now we're going to find congruent triangles. So check this out. Make sure you remember that note. Triangles have 6 parts, 3 sides and 3 interior angles. That's money. So if all 6 parts are congruent, we have congruent triangles until we start learning shortcuts. But for right now, if all 6 parts are congruent, we have congruent triangles. So let's take a look at this. How many triangles do you see? You should see 2 triangles, right? So we have triangle ABC, and then triangle, if I said ABC, this must be triangle EDC. Okay, it has to be. If I go A, the 1 arc angle, to B, the 2 arc angle, ABC, I have to read it from the 1 arc angle to 2 arc angle, EDC. I must read it that way. So remember, if I'm calling this triangle ABC, then this must be triangle EDC. That is incredibly important because once you see that, you can redraw this thing. You can totally redraw this thing to show it like this, and it'll make a whole lot more sense. Okay? A has 1 arc, E has 1 arc. B has 2 arcs, D has 2 arcs. Okay? 1 arc, 2 arcs. Now, AB, segment AB has 1 hash mark, AB has 1 hash mark, then ED has 1 hash mark, ED has 1 hash mark. So once you name it correctly, you can draw it correctly, and that'll help you know some stuff. So the question is, are the triangles congruent? We have to justify our answer. Remember, we need 6 parts of the triangles. So what are the 6 parts? Okay, we have angle A and angle E. We have angle B and angle D. And we have angle C and angle C. It is important that I write angle C twice because I have 2 triangles. Okay, it's super important that I write that twice. I have 2 triangles. And I'll talk more about that in a second. So I have my 3 angles. Now what about my 3 segments? I have segment AB and segment ED. I have segment BC and segment DC, and then segment CA and segment CE. Okay, so these are my 6 parts of each triangle. Okay, and the question is, if they're all congruent, I have congruent triangles up until I find shortcuts later. But if all of these are congruent, I'm good to go. Does that make sense? Awesome. So the question is, are angle A and angle E congruent? Right? So angle A, 1 arc, angle E, 1 arc. Yup, totally congruent. Blam, we can say that. How about angle B and angle D? Here's angle B, 2 arcs. Here's angle D, 2 arcs. Totally congruent. Yes. How about angle C and angle C? Are they congruent? Can we say that they are congruent? You know what these are called, right? Boom, 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 3, boom, 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 3. Why? Why are those 2 angles congruent? Because angle C are vertical angles to one another. What? And vertical angles are always congruent. So those two are definitely congruent because vertical angles are always congruent. So yes, we can say that angle C is congruent to angle C. How do we justify that answer? Because vertical angles are congruent. Okay, so we justify, now testify. Anyhow, how about the segments AB and ED? Well, let's take a look. AB and ED, one hash mark, totally congruent. Yes. Now we have BC and DC. Are they congruent? Yeah, they're both 4, right? So they're 4 units, congruent, and CA is 6, CE is 6, congruent. Same size, same shape. So guess what? We have congruent figures. Are the triangles congruent? Yes. Justify your answer. We just did. So the answer is yes. And how? Because we have 6 congruent parts, the missing piece was angle C being congruent to itself because those are vertical angles. And we can justify that. Okay? Okay. Moving on, next question. Whoop. How about this? Is triangle ABD congruent to triangle CBD? Let's justify our answer. So there's a couple things that we need to know. The first thing is this, that AD and CD are congruent. That's because it's given. Okay, so look at AD and CD are congruent. That's given, one hash mark. So we know that. Now DB is congruent to itself. That's the reflexive property of congruence. Now why is that important? Because remember, we're looking at 2 triangles. Okay, it's really important to keep this in mind. We're looking at 2, actually looking at 3 triangles in the whole. We're looking at 2. We got A, B, D, and C, B, D. Okay, so we're looking at 2 triangles. It's very important to establish that these 2 segments are the same, that DB and DB are the same. Okay, so it's 2 different triangles, but they're the same. So it's very important to establish that there is a reflexive property. Okay, so far we have a congruent side, and we have 2 congruent sides. Okay, do we know of any congruent angles? So remember, we need 6 pieces to justify this, right? Are there any congruent angles? And we can't. Well, you know what we can? We can establish a couple of congruent angles. We're going to learn about this. I may as well teach you now. What we can establish is that angle A and angle C are congruent. How do we know? Because the opposite sides are congruent, therefore the opposite angles must be congruent. It's called an isosceles rule, and we'll learn it later. Okay? So we can learn that later, but still, that doesn't give us these 2 angles or these 2 angles. The only thing we know is that angle A and angle C are congruent. We can tell because they're isosceles, but we'll learn it later. Okay, so we'll call it coming soon to a theater near you. Coming soon. But we don't need to know that right now because the point is we still don't know. We still don't know if B is congruent to itself or if D is congruent to itself. We don't know if A and B and C are congruent. We don't know enough. So can we say that these 2 triangles are congruent? No, we can't say. So is triangle ABD congruent to triangle CBD? No. Justify, we don't know enough angles. We don't have the third side and the other angles. Okay? We don't have all 6 congruent parts, or as we'll learn shortly, the correct congruent parts. Okay, so no, we can't say they're congruent. We don't have all 6 congruent parts. So that is triangle congruence. You guys ready? Ready for the best part? Proofs. Whee! No, Mr. Katz. Yes, proofs. Okay, so look at this. We're going to prove triangles congruent now. Let's give you a setup. Okay, the setup is this. Given this diagram and all the parts of the diagram, LM is congruent to LO, LM, LO. MN is congruent to ON, MN, ON. Angle M is congruent to angle O, angle M, angle O. And then angle MLN is congruent to OLN. So basically it's all the hash marks and arcs. That's what we're given. Okay? So what we have to prove now is that the 2 triangles are congruent. We have to prove that. We have to prove that without knowing any shortcuts, because this is a one-statement proof, but we'll learn that later. So this is a shortcut. So what do we have to show? We have to show that all 6 parts are congruent. That's what we have to show. And some of the reasons that we have a third angles theorem, we have the reflexive property of congruence, and we have the definition of congruent triangles. So these are some statements that are important to know. The third angles theorem, remember that from the notes. If we got 2, we got 3. If we have 2 angles, we got 3 angles. And we have the reflexive property of congruence, so a thing is congruent to itself. And we have the definition of triangles. So the point is, can we show all 6 parts congruent? How many congruent parts do we have right now? We have 1, 2, 3, 4. We need 2 more congruent parts. Okay? So 2 more congruent parts. So let's say we start with the statements. We're going to start with one reason, and that is given. And we're going to make all of these statements over. We know that LM is congruent to LO. We know that MN is congruent to ON. We know that angle M is congruent to angle O. And we know that angle MLN is congruent to angle OLN. All of that stuff we know that's given. That gives us our 4 parts. We need 2 more congruent parts. So which part do you want to start? Okay. So we have all of these that are marked up. We're missing the angles here and here. Okay, we're missing those angles, and we're missing this side here. Okay, so we're missing those. If we can prove those congruent to each other, money, money, money. Anyway, let's go. It doesn't matter which one you want to start with. So let's start with, how about LN? We can start with this side being congruent to itself. Why are we going to use it being congruent to itself? Remember I told you about the reflexive property of congruence. Let's use that statement. Okay, let's use it. Reflexive property of congruence. And that is so important to note. If I'm going to make that my next statement, I have to say that LN is now congruent to LN. Okay, segment LN is congruent to segment LN. And I have now established my 5th piece. Okay, my 5th piece. All I need is one more piece. I need the angles. Okay, so I need angle MNL and angle ONL. Okay, so how can I establish then? Look at the list given. To establish those angles congruent, don't you think we should use third angles theorem? Yeah, I agree. So let's do that. Okay, so we have third angles theorem. Now, what are we going to show with that third angles theorem? We're going to show that angle MNL, okay, is congruent to angle ONL. That's what we're going to show. So if we show those two congruent, we now have our 6th piece. Okay, so that now we have all 6. The sides, the angles, 4 sides, 3 sides, 3 angles. 6 pieces. All of them are congruent now. So what can we do? Well, we're done is basically it. Now we can say the proof. Right? Triangle LMN, if I know how to write the letter N, is congruent to triangle LON. Those are, now we have done, right? We're done. Now what's going to be the statement we use to justify that? The reason? Definition of congruent triangles. So I give that to you. So we can totally do that. Okay? Definition of congruent triangles. And that's how we use proofs with congruent triangles. Okay? I think there's more, but we're pretty much done. This is the bulk of, this is it for the lesson. If you get this, we're good to go. The other thing I want to show you is a quick quiz, and then we'll call it a day. So the first quick quiz, we have this. If UVW, here's UVW, is congruent to EFC, here's EFC, what's the measure of angle FEC? So what's the measure of FEC? What is the measure of this angle? Which corresponds to this angle. Therefore, the measure of this angle, 51 degrees. Okay, hopefully that went quick. Now we have this and a whole bunch of congruent signs. No, cats, no! Suppose angle C is congruent to angle B. Let's make that so. Make it so. Now we suppose angle D is congruent to angle A. Make it so. That is now so. What if AE is congruent to BE? All right, so here's AE, and that's congruent to BE. Oh, that's isosceles. Fun times. And CE is congruent to DE. CE is congruent to DE. Does this prove that the two triangles are congruent? Now, you know what we're looking at? Even though these are vertical angles, okay, even though this is true, do we have 6 congruent parts? Are all 6 of these parts congruent to all 6 of these parts? Hopefully by now you see the answer is no. No. There's no way they're congruent. All right, so no, the two triangles have congruent angles, true, but not necessarily congruent sides with each other. Okay, so if AE was congruent to CE, now we might be talking, right? And if BE were congruent to DE, we might be talking. But even though we still don't know AB and CD yet, there'll be shortcuts coming. So anyway, that is it, folks. Ladies and gentlemen, I have talked enough. So we are now done with the lesson on congruent figures. Okay, so we found congruent parts, we used them, we found congruent triangles, and we did a proof. Whee! So that's it, y'all. I will catch you later.